Today we're going to be talking about factoring. This is really going to be a review of factoring and talking about all the different methods that we've used. But one of the biggest things that's going to be difficult today is that we're now mixing all of our methods together. So not only am I factoring, but I have to figure out what type of factoring I'm doing and work through each one of those. So before we get to any problems, we're going to make a quick graphic organizer just to kind of talk about the process that we should go through as far as determining what type of factoring we have and then getting to those answers. So we're going to create just a little graphic organizer here. As far as size, you're going to need like 4 of these boxes going across, so make sure you give yourself enough room. So first question I'm going to always ask myself is there a GCF? Okay, if there's a greatest common factor that I can pull out right away, that's going to make my problem smaller. So if the answer to that question is yes, then I'm going to factor it out. Okay, if the answer is no, then I just have to move on. If you pull out a GCF, you are not finished. You still have to go back and keep going through the rest of this process. Okay, the next question we're going to ask ourselves, though, is to figure out kind of how big is the expression that we're working with. So we're going to ask ourselves how many terms are there? And we're going to answer that one of 3 ways. We're going to say there's either 2 terms, 3 terms, and then 4 or more terms. Okay, if there's 4 or more, that means I'm not working with a trinomial or a binomial, and so then we're done. Okay, if I could pull out the GCF, then I say that that's what I have, that's I'm finished. If I didn't have a GCF and I get to that point, then we would say that it's prime or not factorable. Let's talk about 2 terms now. So with 2 terms, we had one type of factoring that we did when we were talking about 2 terms, and that was our difference of squares. So that's really what we need to figure out is there a difference? Can we write it as something squared minus something else squared? Okay, if the answer is yes, then fact like we did for difference of squares. So we factor as, and just a quick review, difference of squares is where I took the square root, so I would have a and b, one with a plus, one with a minus. If I answer no to it being difference of squares, then again, just like if it was 4 or more, I'm done. If I had a GCF that I've already pulled out at that point, great. If not, then I would say prime. Okay. 3 is probably the trickiest one. This is where I'm now talking about trinomials. So when I'm talking about trinomials, there's an additional question we have to ask ourselves, and that is, what is the value of a? Okay, and the reason we have to ask ourselves that question is depending on what a was, we factored this 2 different ways. So if a is equal to 1, then we factored it simply by looking for things that multiply to give you c. So we looked for factors of c that sum or add to give you b. Okay, and this is when we're talking about ax squared plus bx plus c. That's where the a's, b's, and c's are coming from that we're talking about. But we had a different way to do it if a was not 1. So if I actually had a number in front of x squared, that's where we had kind of what we talked about yesterday, and that's where this gets a little bit trickier. That's when I look for factors of a and c. That do our outside-inside sum to give us b. So that's where we had to set up that OI table and kind of work through that. So this is kind of our graphic organizer that we're going to be using as we work through all of these problems. The biggest thing from this is we always have to look for a GCF first. If I have a GCF, that needs to get pulled out first because it's going to make my problem a whole lot easier. Let's look at example 16 here and get into some of these examples. So first of all, for example 16, my first question is, do I have a GCF? Well, if I could look at 27 and 12, 12 definitely has a lot of factors, so some of them might work. If I think of my factors of 12, I have 1, 2, 3, 4, 6, and 12. Thinking about those in 27, I think 3 will go into 27, and it'll go in 9 times. So I'll pull the 3 out front. That leaves me with a 9x squared minus, if I pull the 3 out of the 12y squared, gives me a 4 y squared. Now that I have the GCF out, if I go back to my graphic organizer here, I factored it out. I'm going to ask myself how many terms do I have, and this is just in the remaining portion. My GCF is now out front. I'm not concerned with that anymore. I just can't lose it. So I'm looking at this piece here. I have two terms, so is it a different squares? This is something I can square root. 9 and 4 are both perfect squares, and I have an even number for my exponents. So I can do my squared. So I'm going to factor this as a difference of squares. So when I do that, my 3 on the front, I'm going to write my two factors, one with a plus, one with a minus, and I'm square rooting each of these. So the square root of 9x squared is 3x. Put that as my first term on each one. The square root of 4y squared is 2y and 2y. So this here is my final answer. Moving on to number 17. Again, I'm looking first for a GCF. So if I have a 4, a 16, and a 48, 4 definitely goes into 16, and it does go into 48 as well. So I'm going to pull that 4 off the front. That leaves me with an x squared minus 4x minus 12. If I go back to my graphic organizer here, I'm looking at how many terms I have. This is a trinomial, so I'm looking at 3 terms. My value of a on the inside here now is 1, so I'm just simply looking for factors of c that sum to give me b. So if I make myself a quick table here, I'm looking for factors of negative 12 that sum to give me negative 4. Okay, and based on my middle b being a negative, I know that I have opposite signs for the negative 12, and the bigger one is going to be negative. So 12, let's try here. I could do 3 and 4, so we'll do 3 and a negative 4. If I add those together, it gives me negative 1. That one didn't work. Maybe 2 and 6. So I have 2 and negative 6. 2 plus a negative 6 is a negative 4. So that is the one that I want. So to write out my answer here, I'm going to keep my 4 on the front, and then I write my two factors, which are simply x's, with my two factors of negative 12 that I was using. So a plus 2, and then a minus 4. So x plus 2 and x minus 4. Finally, number 18 here. If I'm looking at this one, I'm definitely looking at a GCF. I have an x in every term, so I know I can at least pull out an x. Looks like everything's even, so I could at least do a 2. Can I do anything more? For the 6, I could do 2 and 3. But the 3 won't go into 22 or 40. So I think 2 is going to be the biggest thing I can pull out as far as the numbers. So I'm going to do a 2x on the front. When I do that, 6x to the third, if I pull out a 2x, leaves me with a 3 and an x squared. 22 is going to become an 11. Pulled out one of the x's, so there's still one x left. And if I pull the 2 out of the 40, it gives me negative 20. X is not there either. Okay. Next step, I need to go ahead and make my table here for my outside-inside sum. So I'm looking for things that multiply to give me 3 and negative 20 with an outside-inside sum of 11. So looking at 3, really all I can have is 1 and 3. Negative 20, I have a couple options there. I could do 1 and 20, 2 and 10, 4 and 5. We'll maybe start with the 4 and the 5. So we'll do 4 and 5. Let's just try, one of them needs to be a negative. We'll make the 5 a negative. So if we go ahead and multiply here, I'm going to have a 3 times a 4. We'll start on the outside. 1 times a negative 5 is going to be negative 5. 3 times a 4 is going to be a positive 12. If I add those together, that gives me a positive 7. That one doesn't work. So I could move the negative to the 4, but I think all that's going to do is make this a negative, which might be helpful, but I really still need to switch some stuff around. So let's try switching the first one. Let's try 3 and 4. If I make this a 4 and a negative 5, if I multiply there, 3 times a negative 5 is negative 15. 4 times a 1 is a positive 4. If I add those, I get negative 11. Well, that's close. I have the 11, but I have the opposite sign. So that tells me my negative is just in the wrong place. So we're going to keep the 3 and the 1, the 4 and the 5. But now I'm going to make my 4 a negative. When I do that, I have 3 times 5 is 15 for my outside. My inside is 4 times negative 4, which is a minus 4. That gives me 11. So this is the one that I want. Those are my answers. So as far as writing out my answers, I need my 2x on the front. Don't lose this GCF. If you lose that, you're going to lose points. For my first group, I take my first from each list, so I use the 3 and the -4, but the 3 has the x with it because that's giving me the 3. So 3x minus 4. And then my second group is just the 1x or x with the plus 5. So this here is my final answer. So really what we're working with again is just this graphic organizer, kind of working through those decisions. Okay, really the biggest thing is always look for that GCF first. Once you have the GCF either pulled out or have ruled that there's not one, then how many terms do you have? Are you doing a difference of squares? Is it a trinomial? If it's a trinomial, is it a 1 or not 1? Okay, and those are really our types of that we're doing.